and welcome to the third module. So we have already covered module 1 and module 2. Today we are going to talk on module number 3. So, and what we are going to discuss in this module is the module name is AWS Basic Networking Concept, where in topic 1 we'll be understanding what is IP addressing and what is CIDR, classless inter-domain routing. Then in module 2 we'll be talking on VPC, that is virtual private cloud, and in that we'll be talking on subnet, internet gateway, route table, all these things. Topic 2 will have a understanding of VPC, and in lab number 3.1 we'll be creating VPC with subnet and route table. So first we'll have a theory, what exactly VPC is, what is subnet, what is internet gateway, what are route table. So we'll have a theory. After completing theory, we'll have a separate lab video number 3.1 of lab, where we'll be creating VPC with subnet and route table. Then we have topic number 3, where we are going to talk on elastic IPs and NAT gateway concepts. Topic number 4 will be on VPC security. There we are going to understand NACL, network ACL or network access control list, and security groups. And then in lab 3.2, we'll do a lab on NACL and security groups. So this is what I'm going to show you in this complete module structure. So this module has so many topics to discuss. Let's start with topic number 1. So in this, we are going to understand IP addressing and classless inter-domain routing CIDR. So let's start. Okay, so I'm starting with the topic. Just give me 1 minute. Okay. So IP addressing and classless inter-domain routing. So before I talk on anything, let me write one thing. So I'm writing 192.168.0.0/16. So I'm asking one question to you. What is this? This means this entire thing. What is this? Fine. And if it is something you know, then how many IPs, how many IP address we can create? We can create. So this is my second question. Now, if you know this, then you can answer. If you don't know, you must be confused what exactly it is, what slash means. You have an understanding of this. This is IP address, but what is this slash and all? So this slash represent CIDR. This is called CIDR, classless inter-domain routing. And how many IP address we can create? We can create 65,536 IPs. Now you must be thinking, I don't know how to teach. No, you must be thinking that why this particular man is just giving answers and not explaining anything. So not to worry, I'm going to explain you everything. Fine, let's start. Let me write one IP. So let me write one IP, 192.168.3.25. Let's say this is an IP I'm writing. So you know what is this IP? This IP is IP version 4. So IPv4. So there are versions, IPv6 addresses also. This is IP version 4 IP. And this IP version 4 IP has 32 bits. 32 bits. Now you must be thinking, how 32 bits? The 8 bits, then dot 8 bits, then dot 8 bits, and then dot 8 bits. Again, question coming in your mind. Now these are not 8 bits. This is just 3 bits. This is just 3 bit. This is only 1 bit, and this is 2 bit. How can you write this 888 and you are making it to 32? How can you do this? Fine. So let me give you an answer of this. This is not a bit. This is a decimal notation of binary number. This is a decimal notation of binary number. Actually, binary is converted to decimal and it is written like this. Now let me go in a smaller manner so that I can explain you everything in detail. Let's start. Okay, now let me remove this. So what am I saying is that it is 8 bits, dot 8 bits, dot 8 bits, and dot 8 bits. So total there are 32 bits. Now I'm going to prove you how it is 32 bits. Now if I talk about IP number, so you know, if I talk about binary numbers, not IP numbers, binary numbers. So binary numbers are represented by 0 and 1. Fine. So the first binary number is 2 to the power 0. The second binary number is represented as 2 to the power 1, then 2 to the power 2, 2 to the power 3, 2 to the power 4, then 5, 6, and 7. Why 7? Because I have to talk of 8 bits. So I'm taking from 0 to 7. So anything to the power 0 is 1. Anything to the power 0 is 1. 2 to the power 1 is 2. Power 2 is 4. Then 8. Then 16. And then 32. And 2 to the power 6 is 64. And then 128. Now, I have to write what? Let's say I have to write 0. So if I have to write 0 in binary, then all the digits will be 0. Then all the digits will be 0. So this is what? 0 in binary. This is what? 0 in binary. So in 8 digit, this is 0. If I have to write 1, so how will I write 1? So 1 will be, this number is 1. So I'll be writing this, making it high. Remaining all the digits will be 0. So this is what? This is 1. Fine. And if I have to write 2, so this is 2. Remaining all the digits will be 0. So this is what? This is 2. Now I'm going to write like this. So if I have to write 25, so how I will write 25? Just give me a minute. So if I have to write 25, so how will I be writing 25? 25 means 16 and 8, 24 and 1, 25. Remaining all the digits will be 0. So this is 25 in binary and this is 25 in decimal. If I have to write 3, so how I'll be writing 3? 3 means what? 2 and 1, 3. So this is 25 and this is what? 3. So, and remaining all the digits will be 0. So all the digits will be 0. So this is 3. If I have to write 168, how will I write 168? Now see this. 128, okay, plus 64. So 128 plus 64 will become more than 168. 128 plus, so I'll not take 64. So 128 plus 32, 160, and 160 plus 8, 168. Remaining all the bits will be 0. So this is 168. Fine. And if I have to write 192, so 128 plus 64 is 192. Remaining all the digits will be 0, 0, 0, 0. So this is what? 192. Fine. And suppose if all the bits are high. Now suppose if all the bits are high. If all the bits are high. So this is what? 128 plus 64 plus 32 plus 16 plus 8 is equal to 255. Means this is what? Any octet cannot be greater than 255. Even if all the digits are 1 also, it cannot be greater than 255. So 100% you will never see a IP like 2.321.5.921. How it is possible? If all the 8 bits are high also, it cannot exceed 255. So it is, this IP is, you know, is not possible. This IP is practically not possible. Fine. Hope you are getting what I'm trying to explain you. This particular IP is not possible. So overall, this is how you convert binary numbers, decimal to binary numbers. Fine. Now, if I have to write this in a binary, fine. So 192 is what? Double one, and then 6 times 0. 1, 2, 3, 4, 5, 6. No, this is 192. And what is 168? 168 is 101, 01. So 10101. Okay. And then 000. So this is 168. And then 3. So 3 is what? 0, 0, 0, 0, 0. So 5 times 0 and 6 times 0 and 1, 1. So this is 3. So if I'm not wrong, yeah, 3. And dot, then 25. So what is 25? So 000 11, 000 11, and then 001. So this is how, if you write like this is a decimal notation of IP. And if you write like this is a binary notation of IP. And this is what? 8 bits, 8 bits, 8 bits and 8 bits. Hope now you are getting what exactly I'm trying to explain you. So this is an IP. Now, coming to the question which I have given you, let's say I'm giving you one new question. 192.168.0.0/24. Now, my second question is, what is this called? So this is called CIDR. This is called CIDR, CIDR, classless interdomain routing. So this is class called CIDR, and how many IPs I can create. Now, in CIDR, what happens, whatever you write after slash, that number of bits are blocked. Again, I'm repeating, in CIDR, whatever you write after slash, that number of bits are blocked. So if it is 24, then starting from first, 8 bits, it is blocked, and 8 bits, it is blocked, and 8 bits, 888. So this 24 bits are blocked. So if this 24 bits are blocked, so what is left? Only this is left. Only this can be changed. This will remain same for all. This will remain same for all. If this will remain same for all, what am I trying to say, my dear friend, is that, let's say your organization, this is your organization, fine, and your organization always choose one CIDR, and the CIDR of your organization is this. So according to this CIDR, according to this CIDR, all 3 bits, all these 3 dots bits are blocked because slash 24. So all the devices in this organization will have IP which start from 3 common bits, 192.168.0. This device also 192.168.0. This device also 192.168.0. And after the 4th digit can vary. So it can vary from what? It can vary. And this is what? This is 8 bits. And 8 bit can vary from 0 to 255. So it can vary from 0, it could be 1, this could be 2, and last could be 192.168.0.255. This means now what is this? This is called CIDR. And how many IPs I can create? I can create, if this is 0, so I can start from 0 to 255. So how many IPs I can create? I can create total 256 IPs. So total, how many IPs we can create? We can create, how many IPs? We can create 256 IPs. Now, you must be thinking, have I gone mad? Or I'll be going to do so many calculations in order to get answer. Let's say tomorrow you give 10.0.0.0/2020. So am I going to make such numbers and then I'm going to find how many IPs can be created? Slash 20 means 20 bits will be logged. 20 bits will be logged means 8 bits, 8 bits, 16 bits, and this. So this bit will be logged. This is not going to change, and remaining all going to change. Fine. So this is what. Now, how many IPs I can create? So in this case, don't get confused. There is a proper formula. So formula is 2 to the power 32 minus n. This is the formula. The formula is 2 to the power 32 minus n. Now we were talking about this and we came to a conclusion that we can have 256 IP. Now you put it in a formula. 2 to the power 32, and what is n, which is written after slash? What is that? 24. So what is that? 2 to the power 32 minus 24 is what? 2 to the power what? 8, and 2 to the power 8 is nothing but 256. Hope you are getting how we can calculate 256. Now let's talk about this. 2 to the power 32 minus n. N is what? 20. So here n is 20. Fine. So how many IPs we can create? 2 to the power 12, and 2 to the power 12 is nothing but 4096. Now I was telling you about this. How many IPs I can create for this? Again, slash 16 means 16 bits are blocked, 8 and 8. So what are remaining? This can be changed. This can be changed. So again, put it in a formula. 2 to the power 32 minus n, which is nothing but 2 to the power 32 minus 16, which is 2 to the power 16, and 2 to the power 16 is nothing but 65,536 IPs. So total, how many IPs we can create? We can create 65,536 IPs we can create. So this is what I wanted to teach you on IP addressing and CIDRs. But there are some more concepts which I'll be discussing with you right now. Now, what are those concepts? Let's start. Okay, let me discard all these things. So let me start with a fresh page. So now, right now we have discussed this, that if an IP is 192.168, let's say dot 0 slash 20, how many IPs we can create? We can create 2 to the power 32 minus 20 is 2 to the power 12, and 2 to the power 12 is nothing but 4096 IPs we can create. So total we can create 4096 IPs. This is what we can create. Now coming back to 4096 IPs we can create. Now coming back to what I wanted to teach you, you might be thinking, if you have a good network concept, you might be thinking that two IPs are blocked. Exactly. Two IPs are not available. So what is that? So if I talk about how many IPs are there, so not this -2. This is 4096 minus 2 is 4094. Now why 4094? Because the first IP, that is the first IP, is reserved for network, and the last IP is reserved for broadcast. BROADCAST, broadcast. Fine. So the first IP is reserved for network and the last IP is reserved for broadcast. Let's say 192.168.0.0/24. So how many IPs we can create? We can create 256 IPs. So the first IP 192.168.0.0 is reserved for networks, and the last IP 192.168.0.255 will be reserved for broadcast. So total available will be, so slash 24 means 2 to the power 8 and 2 to the power 8 is 256. So total available IPs will be 256 minus 2, which is 254. But, so I'm writing here, but in AWS, we reserve 5 IPs. So in AWS, we reserve 5 IPs. So what are these IPs? The first IP is for network. Please make a note of it. Second IP is for third. Let me write third, fourth, and last, like this. So if something is missing, wait. So last is for broadcast. Fourth IP is reserved for future purpose. Future. Fine. The third IP is reserved for DNS, and the second IP is reserved for route. So now I was just confused. So what are so 5 IPs? So in AWS, the correct formula will be 2 to the power 32 minus n and then minus 5. So this is what exactly the formula for AWS will be, because AWS reserved 5 IPs. First for network, second for route, third for DNS, fourth for future, and last for broadcast. So this is what overall the IP address concept and CIDR concept is. Now, why am I teaching you this? Because I have to teach you VPC. And if I'm going to teach you VPC and you don't know all these things, trust me, you're not going to understand anything on VPC. So before coming to second video, please take a quick round of this video, solve some question, and then come to the second video, which is on VPC. So at last, I'll only say thank you so much for watching.